Today we're in your packet, we're on day 9, we're in the last lesson in this unit as well, which is called the Law of Sines. So let's kind of look at where we've come from. The first two, if you notice, are right triangles, so that means we can go and use SOHCAHTOA. So again, here's that angle. This side would be the opposite, so that means this is adjacent, this is hypotenuse. AH would be the cosine. Cosine of 37 degrees equals 11 over x. This is the case where we divide 11 by the cosine of 37 degrees. And we end up with 13.8. Okay, second one, here's the angle. Again, here's the side across from it, so this is opposite. This is hypotenuse because it's across from the right angle. OH is sine. So sine of theta is 4.4 over 11. Anytime we're looking for an angle measure, that means we have to do inverse sine. So we are doing inverse of 4.4 divided by 11. And we end up with that angle being 24 degrees. Then yesterday we added on what happens if they're not right triangles, which is the case for number 3 and number 4. If they're not right triangles so far, all we know is we can use the law of sines, which is the sine of an angle divided by its opposite side has the same ratio. So sine of 44 over 7, sine of 53 over x. Cross multiplying. And then ultimately we need to get x by itself so we can divide by the sine of 44. And we end up with, in this case, 8.0. Same thing with the last one. Again, we don't have a right angle. We're looking for the measure of angle C. So again, I see these and then those two go with each other. So we've got sine of C over 21, sine of 88 over 26. Let's cross multiply 26 sine of C, 21 sine of 88. And I'm going to switch to my pen because I'm kind of running out of room. I need to get the sine of C by itself, so I'm going to divide by 26. And I'm typing all of that into my calculator. Just make sure at the end of that 88 degrees you type in a parenthesis. I've got a bad glare, but let's see if we can go show you here. All right, 21 sine of 88, as I said, close that and then divide by 26. We get 0.8072. Now again, we're looking for an angle. That means I have to use the inverse. It has all of those numbers stored in on our calculator. So we can go and do inverse sine of that answer. And that answer button is all the way down here. And finally, we end up with a 54-degree angle. Okay, the last theorem is called the Law of Cosines, and there is a typo here. This down here should be a c squared. And again, same thing as before, A, B, and C are sides, capital A, B, and C are angles. Again, all of these little guys are sides. If they're capital letters, these are angles. And the main connection that you want to see on this formula is whatever side I'm looking for or I have goes here and its opposite angle is here. So look here. Here you have little b, its opposite angle is here. Here you have little a, its opposite angle is here. Now the question is, when do I use this particular law? You use this law when you have got all three sides or two sides and the angle in between them. In other words, you've got side, 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 or side, angle, side. If it doesn't fall into one of those categories, that means we can go and use the law of sines that we talked about yesterday. And again, the only time we're using this is if we start off with we don't have a right triangle. So we're going to kind of look at each of the two cases 2 times. So the first case and the second case, in both cases we're looking for the length of the side. This tends to be a little bit easier to deal with. So we're looking for the length of the third side, which is labeled to be A. That formula says a squared equals b squared plus c squared minus 2bc. Notice these are the same of these, and then the cosine of A. So we're looking for A. We've got b squared, we've got c squared, and then again over here, 2.5, 3.5, cosine of 40 degrees. And we're going to chunk this up just at least a little bit for us. Let's go ahead and plug in all of this, and let's plug in all of this. So I'm typing in 2.5 squared plus 3.5 squared. I've got 18.5, now I'm typing in the rest. So 2 times 2.5, 3.5, cosine of 40 degrees, and I've got 13.405. We're going to go ahead and subtract the 2. So we've got 5.09 is equal to a squared, but we want just a. We're going to go and take square root. Typed in something wrong. I'm coming up with a is equal to 2.3, in this case, miles. Okay, the second one is pretty much similar to it. It says we've been given 2 sides. One of them is 8, one of them is 10, and again, I'm looking for the angle in between. I should say I have the angle in between. I'm looking for the length of the third side. So let's go label this to be x. So again, remember what we talked about in the formula. Whatever I place here, the angle across from it is going to go here. We've got then x squared equals 8 squared plus 10 squared minus 2 times 8 times 10 times the cosine of 40 degrees. And again, I'm going to chunk it up. I'm going to type in that. I'm going to type in that. So here we go. 8 squared plus 10 squared is 164 minus, typing in all of that, 122.567. We're going to go ahead and subtract the 2. And again, I want to know what x is, so I'm going to go and take the square root. And we end up with 6.4. It doesn't really say what the units are. Units. Now, if you feel strong enough, you actually can type in that whole entire thing and jump right to the 41.4. I'm just trying to chunk it up in case you need that. Okay, the last case is a little bit more difficult, but hopefully we've kind of set you up. We've been given the lengths of 3 sides. And it says we're looking for the angle opposite the largest side, so that would be this angle here. let's just label that to be angle X. So again, think back up to the formula. Whatever we put out in front has got to be on the tail end across from the angle that we're looking for, which in this case is angle X. In other words, we've got 15 squared, 10 squared plus 14 squared.